All right, and the last thing I just want to throw in here, because it fits so well, is heat content or heat of combustion. This really isn't in your book at all, which is a bummer, but this really fits in because let's say, and you're going to be doing this in the lab using your makeshift calorimeter. Let's say I want to know, I have an item, a food item, whatever it may be. I want to know how much energy is in there. So what do? I light it on fire and I burn it. And I try to get all the energy out. And where's that energy going to transfer? To the water or whatever solution I have above it. So I can indirectly find out how much energy is inside that item. Understanding the law of conservation of energy and calorimetry. So we're going to find out a lot of information. So once you figure out then your energy gained by your water, we know again that the energy lost by whatever this is going to equal the energy gained by your water. So if you solve then for your Q gained by your water, well, now we're indirectly finding out how much heat was lost by that food item. We can now use this information up here and say, well, the Q lost then by the object, so your energy lost, divided by the change of mass. This would be final minus initial. So this would be after burning, minus the before, which is the before burning. And find out how much of it was actually burned off. So your final minus initial, and this would be your Q lost above it. Both of those should be negative values, so you're going to end up then with a positive heat content. So let me just take you through an example. All right, so here is an example of how to calculate heat content. And what we're looking at here, my nice little picture, is let's say we want to heat up some food. We're at the campfire, we want to boil some water. Well, where does the water get its energy from? It's going to get it from the wood that we burn and release the energy from the wood, have it go to the water so we can cook up some dinner, and have a meal. So here's an example. We have a 250 gram piece of wood ignited and caused the temperature of 2 liters of water to go from 25 degrees Celsius to 45 degrees Celsius. So we want to know what is first of all, the mass of the wood left unburned was 50 grams. That's very important to know. So we want to know what is the heat content or heat of combustion of the wood in calories per gram. This goes to the idea again. The energy lost by the wood will equal the energy gained by the water. So the energy is transferring. Now, we don't know what the specific heat is of the wood. And so, therefore, we really can't go any further in this direction. But because of this, because of the law of conservation of matter, we could then say, well, wait a minute. I have everything I need to know for the water. I know the mass of my water because according to, the density of water, we can then figure out exactly, if I have 2 liters of water, well, I can find out exactly how many mils I have, right? So I could go from liters to mil, and so 1 liter is 1,000 mils, so this would equal 2,000 mils. And because of the density of water, 1 gram per mil is the density for water. So if I have 2,000 mils, then I would have 2,000 grams. The specific heat of water, we could just say, is 1 calorie per gram degree Celsius. And we know that the change in temperature, well, it was 45, which is our final, minus the initial, which is 25. And so now we're going to go ahead and calculate that. So let's do that right now. It should be a positive number because it's energy gain, so 2,000. And then we're going to take 45 minus 25. And so we get 40,000. And this would be cancel, cancel, cancel. And the degrees Celsius over here, cancel, cancel. End up with calorie. And so the energy gained by the water was 40,000 calories. But that has to equal our energy lost by the wood. So the Q lost is equal to negative 40,000 calorie. And now what we could do is plug that into our heat content equation, or heat of combustion, over here. And our Q loss then is negative 40,000 calorie over our change in mass. So we're going to take our final mass minus the initial, and it said that the mass of the wood left unburned was 50, so it would be our 50 minus 250, which is our initial. So that would be negative 200 gram. Divide that out then, so we have negative 40,000 divided by negative 200. And so that would be 200 grams, or sorry, calorie per gram. So what does this mean? It means that in every gram of wood for this sample, there's 200 calories available to transfer. So please make sure that you have that other example question ready. Make sure you go back and review this if you need to. We will practice, 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 and make sure you ask lots of questions when you're in class. So this is Mrs. Ewald signing out. Happy calorimetry.